This video is for Physics of the Universe, Unit 1.4, Solving Motion Problems. Today's essential question is, how does an object's speed affect the distance it travels in time? Hello, baby birds. Today we begin a journey into one of the most foundational concepts in physics, motion. Specifically, we're going to look and focus on three key aspects of motion: speed, distance, and time. These three variables describe how things move through the world, and you'll find they're involved in everything from how you run a race to how a robot delivers food across campus. To help us make sense of these ideas, we're going to follow three everyday scenarios. First, a track runner completing a race. Then, a shopper navigating a grocery store with a cart. And lastly, a delivery robot traveling across a college campus. Each of these examples will help us apply real-world thinking to physics formulas and concepts. By the end of this video, you'll be able to look at everyday motion and ask and answer important scientific questions like, how fast was that? How far did it go? And how long will it take to get there? Let's begin with the core idea of speed. Speed is a measure of how fast something moves, how quickly it covers a distance over a certain amount of time. In physics, we describe speed, or velocity, using a simple equation. Speed is equal to distance divided by time. S is equal to d divided by t. Again, S is equal to speed, d is distance, and t is time. For example, if a track runner completes a 400-meter race in 50 seconds, we can calculate their speed like this. S, speed, is equal to 400 divided by 50, which is equal to 8 meters per second. Let's try another example. A shopper in a grocery store walks 500 meters in 10 minutes. We first convert the minutes into seconds because we want to use seconds when we calculate speed or velocity. And so we'll multiply 10 by 60 to equal 600 seconds. So we have a shopper in a grocery store walking 500 meters in 600 seconds. Then we'll plug those values into our equation for speed, right? Distance divided by time. So we have speed is equal to 500 meters divided by 600 seconds, which is equal to 0.83 meters per second. Meanwhile, a delivery robot might consistently move across campus at 1.5 meters per second. Even though the context changes, the same formula, S is equal to d divided by t, helps us understand how fast something is moving. Whether you're a human or a robot, your speed can be calculated by dividing the total distance you are traveling by the time that it took. Now that we understand what speed is, let's talk about two different ways of measuring it. First, we have instantaneous speed and then average speed, which, yes, they are different. Instantaneous speed is how fast something is going at one specific moment. Imagine looking at your car's speedometer as you're driving. That number tells you your instantaneous speed right at that moment. Whereas average speed is calculated over an entire journey. This includes all the speeding up, the slowing down, and even stopping in some cases. Let's go back to our track runner. That runner might sprint faster during the final 100 meters of the race than they did at the beginning. If we measure their speed just at the final stretch, it would be much higher than the average over the whole race. In the shopping cart example, we have a perfect example of this as well. You push the cart fast down one aisle and then stop to pick up cereal. While you were moving, your speed was higher, but if we take into account the time spent browsing, your average speed goes down. What about the delivery robot? It might travel steadily at 1.5 meters per second, but sometimes it has to stop for obstacles or wait at a crosswalk. That means its average speed over a trip is lower than its normal operating speed. And here's something interesting. Tools like speedometers only show you instantaneous speed. They don't keep a record of how fast you were going 5 minutes ago, or the average for the trip. For a speedometer to calculate average speed, it would need to also track the total distance traveled and the total time spent moving. Think about a fitness tracker on your watch. It can calculate average speed because it records both distance and time over the course of a workout. Let's get into the math of calculating average speed. Reminder, the formula is S, speed, is equal to d divided by t, distance divided by time. So let's apply this to our 3 examples. A track runner. They run 1,600 meters, which is 1 mile, in 6 minutes. First, let's convert the time into seconds, because we always want to use seconds instead of minutes for these calculations. 6 minutes is 360 seconds. So into our equation we plug 1,600 meters divided by 360 seconds, which comes out to be approximately 4.44 meters per second. Let's look at a shopping cart. Someone walks 500 meters through a grocery store in 12 minutes. Well, 12 minutes multiplied by 60 gives us 720 seconds. So into our equation it goes. 500 meters divided by 720 seconds. Again, approximately 0.69 meters per second. And then our delivery robot, if it travels 450 meters in 5 minutes, again, 5 minutes multiplied by 60 seconds, is equal to 300 seconds. Again, into the equation, we have our 450 meters divided by our 300 seconds, which comes out to be 1.5 meters per second. So again, by simply plugging values into the formula, we can understand and compare the motion in each situation. And remember, if the units don't match, in our example is just now, minutes instead of seconds, we have to convert them before calculating. Always use meters and always use seconds unless the question specifically says otherwise. What if we want to solve for distance or time instead of speed? We can just then rearrange the speed equation. So we'll always start with speed is equal to distance divided by time, s is equal to d over t. But to find the distance, we'll multiply both sides by time. Right? That allows us to cancel time on one side and move it to the other, leaving distance by itself. So distance is equal to speed multiplied by time. If I want to solve for time, I'll divide both sides by the speed. That will move speed to the side of the equation with distance. To end up with time is equal to distance divided by speed. So some quick examples. Our delivery robot travels at 2 meters per second for 4 minutes. First, convert the time, right? That's in minutes there. I want it in seconds. We'll take our 4 minutes, multiply it by 60 seconds to give us 240 seconds. Then we'll rearrange our equation or use our d is equal to s multiplied by time. We'll have d is equal to 2 multiplied by 240, which is going to be equal to 480 meters. We can have a track runner. Covers 1,200 meters at a speed of 6 meters per second. I'll use my equation solved for time, which is equal to distance divided by speed. But I'm first going to use my, my units are good there, right? Yeah, sorry, my units are good. So time is equal to distance, 1,200 meters, divided by speed, 6 meters per second. This comes out to be 200 seconds. Then we have our grocery shopper walking 600 meters at 1.2 meters per second. If I want to solve for time, I'll simply take my distance and then divide that by time. So I'll take my 600 meters, again, divide it by 1.2 meters per second to leave me with 500 seconds, which comes out to be about 8.3 minutes. Understanding how you can rearrange and use this same one formula is essential. It allows you to solve for whatever variable is missing within the equation, speed, distance, or time. Now let's bring everything we've learned into the real world. First, we'll time and measure objects in motion. You can use stopwatches and meter sticks to measure how far anything like a toy car or a popsicle stick racer or a rolling ball or even walking students move. Then we can use our equation, speed is equal to distance divided by time, and calculate their speed. This gives you direct experience applying physics to things that you can see and control. Then we'll need to practice our unit conversions. Physics often uses meters per second, but in everyday life, we might use kilometers per hour or miles per hour. If we get anything like that, we'll need to be comfortable switching between those different units. Thirdly, we'll need to practice our multi-step motion problems. These are great for modeling real-world scenarios where speed changes. So let's review our big ideas. Speed is calculated using an equation. S is equal to d divided by t. Speed is equal to distance over time. You can rearrange the formula to find distance or time. Instantaneous speed is what's happening right now, while average speed tells us the whole trip story. Think back to our examples. The track runner had moments of speed change, but we can calculate the average speed to simplify their motion. Remember the shopping cart? That reminded us that pauses matter when calculating average speed. And then with the delivery robot, it helped us understand constant speed and multi-step calculations. At this point, you should be able to generate a full and appropriate response to today's essential question. How does an object's speed affect the distance it travels over time?